Let's have a look at some key terms that you need to know about statistics. So statistics is about estimating information about the whole group of data you have using a smaller group. So first two words are population and sample. So the whole group that we've got of data is called a population, and a smaller group within the population is called a sample. So you can think about that if you are taking the whole population of the UK and you want to just survey a few of them to try and guess what the whole population thinks. That means you're taking a sample of that population. The sample that you take needs to be what we call representative. So when we choose a sample, it is important for it to be representative of the whole population, so that the measurements taken in the sample can be used as estimates for the whole population. And to be representative, the sample needs to be big enough to be reliable, and the sample should be random so that every member of the population is equally likely to be chosen. So to link that back to the previous example, if you were surveying the UK, but you just wanted to survey a sample, you couldn't just pick lots of people from one city to survey. You'd need to pick lots of different people from around the country to understand what different people living in different areas meet, and also different people think even, and also what different people with different backgrounds think. You also need to know how to choose a random sample. So to choose a random sample, one of the ways to do it is to assign a number to each member of the population, and then use a computer or a random number table to pick numbers out of a hat to choose a random selection of numbers. And then you pick those members corresponding to the numbers, and that should give you a random sample. Now, it is possible to have what's called a biased sample. A biased sample is one that doesn't represent the whole population. Now, to assess whether a sample is biased, think about whether any groups of the population would be excluded from the sample. For example, based on gender, age, different interests, habits, where they live, things like that. Now, a small sample is likely to be biased. So the bigger the sample, the more reliable your results are. So let's recap some of that by asking some questions. So Jim wants to know what proportion of people travel to his school by bus. He asks 20 of his friends at the bus stop. Is the sample biased? Well, there's a couple of things going on here. First of all, he's only asked people stood at the bus stop, so that's likely to be a biased sample because they are probably taking the bus. And so people using other methods of transport are excluded from the sample. And another way that he could improve his sample is by asking more people. So the entire group under study is called the population, and a smaller group within that population is called a sample. Now, there's two different types of data that you need to know about: primary and secondary. Now, primary data is the data that you've collected yourself, and the data from any other source, including a book or an internet, is what's called secondary data. Now, you also need to know about qualitative and quantitative data. Now, qualitative data is descriptive or categorical and uses words rather than numbers, for example, colors or names. Now, quantitative data is measured in numbers and represents quantities, for example, the heights or shoe sizes, things like that. A good way to remember this is that quantitative sounds like quantity, which is numbers, and qualitative sounds like quality, which is, you can remember that is to do with using words or descriptions. You also need to know about discrete and continuous data. So quantitative data is discrete. Remember, quantitative data is the ones we're using numbers. It's discrete if the numbers can only take certain values. So for example, whole numbers, that is an example of a discrete set of data because you can't take the numbers in between the whole numbers. A continuous set of data is something that has numbers that can take any value in it. So for some examples, discrete set of data might be your shoe size. You can only be size 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, etc. But a continuous set of data might be the heights of people, because you can measure that right down to the millimeter, even smaller, how tall people are. So which of the following is primary data? I'm just going to run through these. So the data collected by government on smoking rates, or the data collected on by teachers about their favourite chocolate bar. So if we're thinking about primary data, the teacher has collected their favourite chocolate bar. They've collected that themselves. Now, another example of some primary data would be some data from taking a survey of your family on the length of time spent sitting down in a day. Some secondary data might be the data about some Premier League goal top scorers. And lastly, another example of primary data is data collected by asking your friends to fill in a questionnaire about video games. And some official data on GCSE statistics might be an example of secondary data. Now remember, discrete data is when the data can only take certain values. Now the capture-recapture method can be used to estimate the population size from a sample. So the process of this is, a sample is captured, tagged and released. Later, another sample is taken and the number of tagged members is noted. And then using the assumption that the proportion of tagged members in a population is the same as the proportion in the sample, you can estimate the population. So just to run through an example, because it's not that easy to understand. A biologist captures 15 turtles from a lake and marks their shells with paint. The next week he captures 20 turtles and finds that 5 have their shells marked. Now you can work out the size of the population by thinking, okay, I've got 5 out of 20, write that as a fraction of my turtles have paint on their shells. And if we think originally I had 15 out of the total population that I captured, so 15 divided by whatever the total population is the same as 5 divided by 20. Now if you work that through and find out what this total population size is by doing some calculations to the equation 5 over 20 is equal to 15 over n, if n is the population size. That will tell us that n is equal to 60 and the population size is 60. So a survey is taken of mice in a field. 10 mice are captured and fitted with a little tag and then released. The following day, 6 mice are captured and one of these mice have a tag on them. How many mice can we estimate are in the field? Well, if you think on the second day, 1/6 of the mice captured have the tag on them. So we can assume that the same proportion of mice captured on the first day are also in the whole population in the field. So we had 10 mice captured on the first day. That will tell us that we can estimate that there are 60 mice in the field. Now, what is a way to make a sample less biased? Is it to make it larger or smaller? To make the sample larger or smaller? If you want to make a sample less biased, you can make it larger, and that will do that for you. So to think about continuous or discrete data which can be any value, is described as continuous, and data which can only take certain values is called discrete. Another question about surveying, the capture-recapture way to survey a population. So a survey of mice is taken in a field. This time 20 mice are captured, fitted with a tag and released. The following day, 8 mice are captured, and 2 of these have tags on them. How many mice can we estimate are in the field? So if 2 out of 8 on the second day are captured and have tags on them, we can assume the same proportion of the population was captured on the first day. So when we captured 20 on the first day, we can say that the same population, same proportions within the population. So if 20 mice are captured on the first day and 2 mice out of 8 are captured on the second day with a tag, then we can assume that there are 80 mice in that population.